Okay, so let us start. We discussed today for cointegration test, and you can remember cointegration test is necessary for estimating the relationship between two or more integrated series. That is, in time series, if the variables are integrated, that is, if they contain unit root, Euler's regression in many cases may provide spurious regression. So for meaningful estimation, we have to look at whether the variables are co-integrated or not. So for that purpose, we want to use our national accounts dataset as we have used earlier, and let us select two variables for today's class. One is GDP at market price. You can look at in the variable window GDP underscore MP. This is GDP at market price, and we can select another variable PFCE. PFCE means private final consumption expenditure. So it is actually the aggregate consumption expenditure, as you are familiar with the macroeconomics. So we are considering two variables. One is GDP at market price, that is national income. Another one is private final consumption expenditure, that is aggregate consumption expenditure. And we want to examine the relationship between income and consumption. That is the traditional consumption function as popularly used in macroeconomics. So today's task is to look into the relationship between aggregate consumption and aggregate income. So for that purpose, we are choosing two variables, PFCE, measuring aggregate consumption, and GDP underscore MP, measuring national income. So first of all, as you know, before starting, you have to open the log file. So please open the log file and generate GDP market price in as a new variable log form. So G ln underscore GDP MP is equal to ln of GDP MP. So we are generating a new variable log of national income, log of GDP at market price. Similarly, we are generating another new variable in log form, G ln underscore PFCE is equal to ln of private final consumption expenditure. Okay. So we want to use these two variables in log form. One is log of GDP market price, another one log of private final consumption expenditure. Now, before starting any kind of time series exercise, you have to set your data as a time series data. So for that purpose, you have to put a command tsset time. Because we have generated earlier the time variable. Originally in your data, the time variable was in the variable name year, and which was in string format. And for that reason, we have converted this string variable into a numerics one. So we are using time as the time variable that starts from 1950 and ends at 2018. Okay. So
স্যার কিছু এখনো পার্টিসিপেন্টস আছে বলছে একটু অ্যাডমিট করে নেওয়া যাবে?
হ্যাঁ, নেওয়া যাবে। So after setting a time variable, let we look at the time behavior of the series. We want to estimate the relationship between them. So TS line for time series line, log of GDP, log of consumption expenditure. So if we look at the behavior over time of both the series, they are not exactly parallel, but roughly parallel, not exactly parallel. And if you look at the fluctuations in both the series, they are also roughly similar. Okay. So the blue line indicates the log value for GDP market price and red.
স্যার গ্রাফটা দেখা যাচ্ছে না।
গ্রাফটা দেখা যাচ্ছে না?
না স্যার।
তোমরা ড্র করে নাও টিএস লাইন, এই মেন উইন্ডোটা দেখা যাচ্ছে? Have you seen the main
হ্যাঁ স্যার মেন উইন্ডোটা দেখা যাচ্ছে।
Okay, so you can plot it. Put the command TS line log GDP market price and log GDP private final consumption expenditure. Okay.
স্যার এই জায়গাটা আপনি বললেন না যে দুটো প্যারালালি দেখা যাচ্ছে, ওটার ইন্টারপ্রিটেশনটা আরেকবার বলবেন?
Parallel, roughly parallel, they are not exactly parallel. তার মানে হচ্ছে যে ওভার টাইম জিডিপি at market price যেভাবে মুভ করছে, প্রাইভেট ফাইনাল কনজাম্পশন এক্সপেন্ডিচার একইভাবে মুভ করছে। Okay. Now,
ওকে স্যার।
suppose we are not concerned about the time series behavior of the variable and we just estimate the relationship between them by applying OLS. So how do we get the result? So regression for linear regression, log PFCE, log GDP-MP. So this is the command for linear regression model. So we are estimating first the relationship between log of private final consumption expenditure and log of GDP market price by considering consumption expenditure as a dependent variable and GDP market price as an independent variable with OLS. So the result looks like this. And if you look at the result, it is highly significant. The value of R squared 0.998 and all coefficients are highly significant. Now, as they are time series variable, if we want to use OLS, simultaneously we need to test whether serial correlation presents or not in your model. So in testing for serial correlation or auto correlation, you know the popular method of testing Darwin-Watson test. So we can carry out the Darwin-Watson test. E stat D Watson. So this is the command for Darwin-Watson, D Watson. This is the statistics for Darwin-Watson test. So what we are looking here, although the individual coefficients are highly significant, t-values are significantly high, both for the GDP market price as well as the intercept term. R square is very high, nearly equal to 1. But Darwin-Watson is very low. You know, if the value of Darwin-Watson is nearly equal to 2, there is no autocorrelation. But if the value of the Darwin-Watson deviates from 2 nearer to 0, it indicates the presence of autocorrelation or presence of serial correlation. So from this result, we can say that although
Sir, can you please repeat, please?
In this result, we have individual coefficients are highly significant, but at the same time, Darwin-Watson is very low. Darwin-Watson estimated value 0.177. So it is significantly less than 2. If the Darwin-Watson is equal to 2 or nearly equal to 2, then there is no autocorrelation in your model. So if the Darwin-Watson is less than 2, it indicates the presence of autocorrelation or presence of serial correlation in your model. So this result indicates that the estimated values you have by applying OLS may be spurious. Okay, so spurious regression is indicated by this symptom, very, very high value of R square along with very low value of Darwin-Watson. So if you have very, very high value of R square, as we have got here, 0.998, and very low value of Darwin-Watson, it indicates this result is spurious. And you know, in economic theory, consumption expenditure may be related to income. So in economic sense, you may have a meaningful result, but there are some properties of the variables or the data which makes this kind of estimation spurious or nonsense. The result you have got here, the coefficient for GDP 0.8690, it is actually the MPC, marginal propensity to consume. So according to these estimates, marginal propensity to consume is 0.86, that is 0.9 roughly. So this value of MPC may not be meaningful because here, although the model is highly fitted according to R square 0.998, but it contains serial correlation, autocorrelation, because the value of Darwin-Watson is very low. So if you have this kind of situation, high value of R square along with the very low value of Darwin-Watson, then you should not accept this result. So we have to look into the result or look into the relationship by applying the alternative method. So this may not be the appropriate method if R square is very high, Darwin-Watson is very low. Okay, and you can get this kind of result even if you take any kind of variable, although actually they are not really related, but if you put your data and run the OLS regression, you will get significant result. For example, suppose your Y variable is GDP and X variable is number of car accidents. So logically, GDP cannot be related with the number of car accidents. So if you have the time series for car accidents, time series for GDP, and if you apply this model, in that case also, you will get a highly significant result. That is, number of car accidents explains highly the value of GDP. So in that sense, it is nonsense or spurious. So for that reason, we have to look into the relationship between two or more time series variable, not just by estimating the model by applying OLS. We have to consider so many things before estimating the relationship between them. Okay, and this kind of situation appears particularly if the variables are integrated, if the variables are non-stationary with unit root. So if the variables are non-stationary with unit root, in that case, the possibility of getting spurious result is significantly high. But if the variable, although they are time series, but they are stationary, for a stationary series, you can safely apply OLS. This kind of model could be applicable or maybe meaningful if the variables you are using are stationary. So for non-stationary series, there is a problem in estimating a result. So before estimating the relationship between two or more time series variable, your first task is to look into the order of integration of the variables. In other words, before using the variables in your estimating model, you have to check whether the variables contains unit root or not. And you know how to check unit root. You are familiar with the unit root test, and you have performed different types of unit root test, uh, Dickey-Fuller test with considering breakpoint, or stationarity test like KPSS. So many tests are available. So you can apply the tests to find out whether they contain unit root or not. Now, here our basic objective is to find out the relationship between them. Our basic objective is not to analyze the trend. So as our basic objective or main focus is to find out the relationship between two or more variables, we carry out unit root test, not in detail, just by following the conventional Dickey-Fuller. But before using Dickey-Fuller test, you have to check the optimum lag length or the order of autoregression presence in the series, and you know all these steps by applying the command varsoc space the variable name, you will get the optimum lag length, and accordingly you can select the order of autoregression. Okay, now you know in cointegration theory, if the variables are of same order of integration, then there is a possibility for cointegration. So if the variables are integrated of same order, then we can proceed for cointegration, otherwise not. If the variables are integrated of different orders, there will be no question for cointegration test, because in that case, you will not get any kind of meaningful result. Okay. So before applying our conventional model, our next task is to carry out unit root test. Unit root test for what? The variables we are considering. So perform unit root test for GDP at market price, log value, and PFCE in log value. So I am using here simply D-Fuller. So there is spelling mistake. So this is the result for Dickey-Fuller test. Okay. Have you seen this screen?
Yes, sir.
Yes, sir.
The test statistics 4.16. So if test statistics is positive, whatever may be its value, the series will be non-stationary with unit root. Okay. So the level of the series contains unit root. Now carry out the same test by taking its first difference, D dot. So after taking first difference, log GDP at market price becomes stationary. So we can infer that GDP, log GDP at market price is I1, integrated of order 1. It contains one unit root. Similarly, you can carry out the same test for consumption expenditure, log PFCE. So in that case also, the T statistics 5.023 positive. So there is a possibility for unit root. Again, D dot, the first difference is stationary. So both the series are I1 according to the Dickey-Fuller test. Now you have to keep in mind, because of the time constraint, we are carrying out unit root test simple Dickey-Fuller without considering the detailing of the methodologies. Detailing of the methodologies means you are aware of the limitations of the Dickey-Fuller tests, and for that reason you have to check whether there is any break or not. If break presents, you have to incorporate the breakpoint to the unit root test, and ultimately you will get the proper result. So suppose we are assuming that both log GDP market price and log of private final consumption expenditure both are I1. Okay, that is, both the series are of the same order of integration. That is, they contain the same number of unit roots. Both the series contains a single unit root. Okay, so log GDP series contains one unit root. Log consumption expenditure contains one unit root. That means both the log GDP series and the consumption expenditure experience roughly similar kind of stochastic trend. The nature of stochastic trend presents in both the series are similar. If the number of unit roots in the two series are not the same, suppose in log GDP market price contains one unit root and consumption expenditure contains two unit roots. In that case, the stochastic trend presents in the GDP series will be different from the stochastic trend presents in the consumption expenditure. So nature of the stochastic trend in that case will be different. Okay, so to check whether the both series exhibits similar kind of stochastic trend or not, we have to find out the number of unit roots present in the series by carrying out Dickey-Fuller test or modified Dickey-Fuller test, or by incorporating the breakpoint Zevot-Andrews. So Zevot-Andrews is most familiar among them. So you can apply this test to find out the order of integration. Clear? Now, as the both series are integrated, that is, as the both series, both the GDP as well as the consumption expenditure contains unit root, for that reason, simple OLS provides you spurious result. If the both series are stationary, in that case, OLS will provide you the meaningful result. But if the series you are using for estimation contains unit root, in that case, you will get spurious result. For that reason, we should avoid simple OLS to find out the nature of relationship between two or more time series variables which are integrated, that is, which contain unit roots. So if they contain unit roots, what to do? In that case, we have to find out whether they are co-integrated or not. So co-integration simple means, if we concentrate on the definition of co-integration, co-integration means co-movement. Integration means order of integration, that is number of unit roots. So integrations are co, that is similar type of integration. So if the variables we are using for estimation follows similar kind of integration, then they may be co-integrated. So co-integration means similar kind of integration or similar kind of stochastic trend or co-movement of the stochastic trend of the variables. So if the variables we are using for estimation contains similar kind of stochastic trend, then we can get meaningful results. Why? Suppose in this case, we find GDP contains 1 unit root, consumption expenditure contains 1 unit root. That is the type of stochastic trend both in GDP and consumption expenditure are similar. For that reason, the nature of stochastic trend in both the series are similar. So what does it mean? That is the trending behavior of GDP follows the trending behavior of consumption expenditure, or the trending behavior of consumption expenditure follows the trending behavior of GDP. So in that sense, the GDP and consumption expenditure may be causally related. That is, the trending behavior of GDP is following the trending behavior of consumption expenditure or vice versa. So for that reason, we can carry out unit root test only when the variables exhibit similar kind of trend, similar kind of stochastic trend. Now we have 2 minutes remain for this session, because you know in Zoom we allow maximum 40 minutes. So we can start again after 2 minutes. So you should keep in mind we have 2 minutes remain, so we can discuss some preliminaries about cointegration test before starting formally the cointegration test, because we cannot completely cover a meaningful part within 2 minutes. So what I am trying to say, the meaning of cointegration means co-movement of the series. That is, the nature of stochastic trend of the series should be similar, and if they are similar, just try to remember the basic form of the simple linear regression model. In this case, as we have two variables, so we have a simple linear regression model. Yt is equal to beta naught plus beta 1 xt plus epsilon t. Here Yt is the final consumption expenditure and xt is the GDP. So this is the linear regression model we have, and in this case we can define the random error epsilon t is equal to Yt minus beta naught minus beta 1 xt. That is the linear combination of the variables provide you the linear the random disturbance. Okay, so random disturbance can be looked at as the linear combination of the variables we are using. So let we stop here and we start again with a new link for the meeting, because time is a few seconds we have left.
স্যার আপনি একটু পাসওয়ার্ড আর এটা পাঠাবেন আইডিটা, কারণ আমি ইয়ে করতে পারছি না, আমি অন্য ফোনে করছি তো তার জন্য বললাম।